Proof of rhombus properties. Rhombus is a parallelogram with all sides equal. So now as it is a parallelogram, it satisfies all the properties of parallelogram like opposite angles are equal, adjacent angles are supplementary, and diagonals bisect each other. So these are properties of parallelogram, and we have a video in which we have already proved the parallelogram properties. You can check the description for the link. Now, because of this additional element that all the sides are equal, there is another property that a rhombus satisfies which the parallelogram doesn't satisfy. It is like diagonals bisect each other perpendicularly. We'll see how to prove that property here. Consider the rhombus ABCD. In this rhombus, join the diagonals AC and BD. They intersect at point O, which is called as point of intersection. Now, as per the definition of rhombus, all sides are equal, which means that AB equal to BC equal to CD equal to AD. Now, regarding the property of parallelogram, which states that diagonals bisect each other, from that we can write the AO equal to CO and BO equal to DO. Now, consider two triangles AOD and AOB in the figure. And from these triangles, we can write that AD equal to AB, that is sides of rhombus and they are equal. And DO equal to BO, BD diagonal gets bisected at point O. So these two portions will be equal to each other. And AO is common for both the triangles. Now all these are sides, so we can tell that both the triangles are congruent using SSS property. Now if we apply the congruency to rest of the elements, that is for angles, from the first side we can tell that the angles opposite to this side should be equal. For AD, the opposite angle is AOD, and for AB, the opposite angle is AOB. Now from the figure we can see that these two angles form a linear pair. Linear pair means sum of the angles will be equal to 180. And we also know that these angles are equal. On substituting that, we will get each angle is equal to 90 degrees. As this angle is 90, we can tell that both the diagonals are perpendicular to each other. Hence, we have proved that diagonals in a rhombus bisect perpendicularly.